Welcome to part 2 about geological and hydrogeological parameters and conditions for groundwater heat exchangers. Let's take a detailed look into the parameters that are important when we want to assess the potential for groundwater heat exchangers. So let's start with the hydraulic conductivity, or the K value. This is a measure of a material's ability to allow water to flow through it under a hydraulic gradient. It depends on the permeability of the material as well as the viscosity and density of the fluid, in our case, water. The intrinsic permeability is specific for the rock type and the porosity. It's a material property that depends on the grain diameter and the geometrical properties of the pore space. So that's the distribution and connectivity of the pores. The hydraulic conductivity ranges from around 10 to the -2 meters per second of gravel to around 10 to the -6 meters per second of silty sand for our porous aquifers. Below that, hydraulic conductivity is considered not feasible anymore for any wells, so this includes the groundwater heat exchangers. The hydraulic conductivity has a strong impact on the design of groundwater heat exchangers because it determines the heat transport in the groundwater. This is what you see here. A high conductivity enables a quick compensation of the temperature change, but this also means longer thermal plumes, as you can see here on the left side, that could potentially affect existing users downstream. If you have a low hydraulic conductivity, the area covered by this thermal plume is smaller. Because heat is dissipated slower, this is good for the downstream users, but it enhances the probability for a short cut between the extraction and the injection well. Then we move to the depths of the groundwater. Depth to the groundwater level is essentially this thickness of the unsaturated zone, which serves as isolating layer from the surface. As we will see later on, this means a lesser temperature variation in greater depths. A small depth means low pumping lift and also lower costs of pumping. Especially if you have a confining layer, that means a more or less impermeable layer with a low hydraulic conductivity on top of your aquifer. It is well protected from possible contamination of the surface. And these aquifers are often protected for drinking water purposes. The groundwater's thickness, a large groundwater thickness, means that you have more resources for the groundwater heat exchangers because there is more groundwater available. But be aware that groundwater level can change over time, even within 1 year or over time. Example given due to overexploitation, and you see both of these scenarios here in this graph. This can change the depth to the groundwater level and the groundwater thickness as well. In the planning phase, this has to be considered in order to prevent the extraction well from running dry and also the injection well from causing flooding. Another parameter depending on the water level will be explained in the next part.